Hello, this is an introduction to my feasibility study of restaurant and bar operations in artificial gravity. Currently, the commercial space industry is experiencing rapid growth. Part of that growth is coming from the expanding space tourism market, which in 2025 was responsible for $1.26 billion, and that number is expected to grow to $3.125 billion by 2031. Part of this is going to be the emergence of orbiting hotels and commercial space facilities. Voyager Station is expected to be the first ever orbiting hotel, is going to open by 2027, with Star Labs and Orbital Reef being commercial space facilities, expecting to replace the International Space Station by 2030. So for the first time in our history, we're transitioning from a space exploration market to also space hospitality. And there's going to be a shift from just focusing on astronaut survival to actual luxury guest experience. The core problem is there is currently no existing restaurants or bars in space. There's also going to be challenges when operating in artificial gravity. There's going to be limited empirical research in space hospitality, and also there is no operational or service models that currently exist. Why the artificial gravity matters? The Voyager Station and commercial space stations are all going to be running with centrifugal force, which creates artificial gravity, which is the equivalent of lunar gravity, which is 1/6 of Earth's gravity. So this impacts our cooking methods, liquid behavior, staff movement, sanitation and waste, and logistics. Things that we take for granted here on Earth because they're automatically implied. These are things now that we actually have to focus and figure out how that's going to work in that new environment. In general, the space economy in 2024 was responsible for $613 billion, expected to increase by over $1 trillion by 2032. The commercial space sector is the dominant aspect of that, creating 78% of those revenues. Hospitality is slated to become a key segment in the space economy, and also food and beverage is going to be essential to space tourism success, because no one's going to stay in a hotel in space without really good food or beverage options. There is a big gap in the research. Right now, when we look at food in space, we're looking at astronaut nutrition and survival, not luxury dining. Also, the International Space Station is an operating laboratory. It's not a hospitality environment. And the market demand is going to be completely different from what we currently have. So right now, there's actually no research on how to run restaurants in space. So the purpose of my study is to address these challenges, address operational and logistical challenges, develop a framework for space hospitality, and also really focus on the operation management and supply chain logistics aspect of this. My research approach is going to be a mixed methods design. We have qualitative studies that's going to involve operations and efficiency, with my quantitative studies looking at the logistics and cost reduction. I chose mixed methods because with limited data, we need all the multiple perspectives and information we could possibly collect. My objectives is going to identify operational challenges, develop these frameworks, and also create cost-efficient logistics models. Because when we're looking into launching supplies and people into space commercially, there's not much room for error. My biggest research question: how will restaurants and bars operate in artificial gravity? $1 million question. With qualitative research being done with the effects of food prep and service, and also efficiency strategies. And the quantitative part, we'll be looking at the cost reduction via supply chain, and the logistics, and the economic feasibility, if this is even worth doing. My first null hypothesis is that the supply chain optimization does not reduce costs. And my alternate hypothesis is supply chain optimization does reduce cost. And my second null hypothesis is the logistics design does not affect feasibility. And the alternate hypothesis of that is the logistics design does affect feasibility. The importance of this study is it's going to support space hospitality development. It's also going to improve guest experience, which, considering that the initial guest we have is going to be a very small portion of our population, is very important that we make sure they're very happy. This is also going to provide foundation for future research and help policymakers create safety standards. The contributions from this study will include new operational frameworks, logistic models for space supply chains, and we'll be able to apply these to space tourism and also remote harsh environments here on Earth. The practical implications of this study is to look at food safety standards in space, efficient supply chain systems, reduce payload costs, and increase economic feasibility, because none of this matters if there's no profits involved. The impact of the study goes well beyond orbit. These frameworks and models could also benefit trips into deep space and to the moon, future aerospace logistics, and commercial space industries. With this study focusing mainly on orbital hospitality, this opens the doors for future research on hospitality on the moon, on human behavior in artificial gravity, long-term operational models, and space guest experience design. In conclusion, space hospitality is a rapidly emerging market. Restaurants and bars are going to be essential, but they're not explored yet because they don't exist. And this study is going to build the first foundation for operations, logistics, and industry growth. I look forward to continuing this research. Thank you.